Hi, today we are looking at section 9.2, which is solving trigonometric equations algebraically. Now, when solving algebraically, for most of our functions, we'll want to move everything to one side and simplify it as much as possible. We'll then use our cast rule, which you should have learned in grade 11, to solve our equation if it equals a fraction. If our equation equals 0, 1, or -1, we can use our knowledge of our graphs of our trig functions to solve. But reminder of our cast rule. It's called cast rule because we can write out cast starting in this quadrant and working counterclockwise, so C-A-S-T. So in this quadrant of A, all ratios are positive. In this one, that's S, sine is positive. This one for T, tangent is positive. And this one, cosine is positive. So you'll notice that for every ratio, there's two quadrants where that ratio is a positive number. For sine, it would be quadrants 1 and 2. For cos, it'd be 1 and 4. For tan, it would be 1 and 3. Now, if each ratio is positive in two quadrants, it's also negative in two. For example, if sine is positive in these two, it's negative in these two. So that's our review of cast rule from grade 11. So, example, solve 7 plus 2 sine x equals 4 sine x plus 5 over the domain from -360 to 0. So this is somewhat similar, but a bit more complex from the questions you dealt with in grade 11. So instead of going from, say, 0 to 360, we're going to deal with other domains. So we've got our -360 to 0, and we might have a bit more rearranging than we did in grade 11. So first thing I would do is move all of the sine functions to one side, and then the numbers to the other side. So I'm going to subtract 2 sine of x from both sides. And then I'm going to move this 5 to the other side. So that gives me 2 is equal to 2 sine x. Now I'm going to divide both sides by 2. So that gives us 1 is equal to sine x. Now, in this case, it equaled 1, so we'll utilize our graph of sine to solve this. So we know our graph of sine looks something like this, and we know it's going to go this way over here. Now we should know this maximum in our first period is going to occur at 90 degrees, and that's at a value of 1. However, that's not in this domain, so we actually want to find our corresponding point here, because we know if this is 0, it's repeating every 360 degrees, so this would be -360. So this technically here would be -270 degrees. So x is equal to -270 degrees. Next example, solve cos of 3x equals -1 over the domain from -2 pi to 0. So this is another change from Precal 11, is we're also going to have functions that are compressed horizontally, as well as domains that are in radians. Now this one we don't have to rearrange at all. because essentially we have our cosine function on its own. We have it equals -1. So what we actually want to do is solve for what our free x equals. So if we rearrange that, free x equals cos -1 of -1. We can solve for what this is by knowing what our graph of cosine looks like. So our graph of cosine starts at its maximum, goes to its minimum, back up to its maximum. It is at a value of -1 here, and that is at pi. So essentially cos -1 of -1 is 1. So we've got, or sorry, is pi. So we've got free x is equal to pi. So our first value is going to be pi over 3. Except for that's in the positive side, and we're going from -2 pi to 0. We also have this horizontal compression, so we know it's going to repeat several times. Now, because we have this 3 in front, that means our period is going to be 2 pi over our b value, so 2 pi over 3. So we'll take this pi over 3 and subtract 2 pi over 3 to get into our negative domain. So that gives us our first answer of -pi over 3. Now it's going to repeat again in 2 pi over 3 units. So we have got -pi over 3 minus 2 pi over 3, which gives us -3 pi over 3, which is -pi. Now we'll take that -3 pi over 3, subtract another 2 pi over 3, and that gives us -5 pi over 3. So that's still within this domain. We'll try one more. So -5 pi over 3 minus 2 pi over 3. So that gives us -7 pi over 3. Now -7 over 3 is large, or is less than -2. So therefore this one's not an answer. So our answers are x is equal to -pi over 3, -pi, and -5 pi over 3. Now, an additional thing that we didn't have to deal with in Precal 11, but we now have to deal with in Precal 12 is having exponents on our trig functions. So our first step is still to get that trig function on its own. So we're going to move this 2 to the other side by dividing both sides by 2. So this gives us cos squared x equals 1 over 2. Now our next step, take the square root of both sides. So that gives us cos x equals, whenever we take the square root, we have positive or negative. So that would be, we can take the square root of 1, so 1 over root 2. So because our function is equal to plus or minus, that means it's actually going to be in all 4 quadrants, because it's going to be in the 2 quadrants that cos is positive and the 2 quadrants cos is negative. Now, each of these reference angles has the same ratio. So if we've got the same reference angle for them all, so we'll just solve for a reference angle in quadrant 1, then get all of our angles. So we know cos is adjacent over hypotenuse. So our adjacent's 1, our hypotenuse is root 2. We should recognize this as one of our special triangles. So it's our 45-degree triangle, which we know 45 degrees is pi over 4 radians. So one of our answers is pi over 4. We have this reference angle here. So going from here to here would be pi minus pi over 4, which is 3 pi over 4 radians. We also have a pi over 4 radians here. So we know that essentially going from here to here would be pi plus pi over 4. So that's going to give us 5 pi over 4 radians. And finally, we have from here all the way to here, we know this reference angle is pi over 4. So that's going to be 2 pi minus pi over 4. So that's 7 pi over 4 radians. So our answers are x is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, if we have an equation with a trigonometric function to a second degree, so for example, sine squared x or cos squared x or tan squared x, and a trig function of degree 1, so for example, sine x, we can factor it or use a quadratic formula to help us solve it. So for example, we've got cos x equals 1 minus 3 cos squared x over a domain from negative pi to positive pi. So I can see I essentially have a cos x, I have a cos squared x, I also have a constant. So I'm probably going to want to move everything to one side. So I'm going to move everything to the left side of the equation. To do so, I'm going to add 3 cos squared x to both sides. And I'm going to subtract 1 from both sides. So that gives me 3 cos squared x plus cos x minus 1 equals 0. Now, in this case, because I'm looking at this to factor, with modified product sum factoring, we'd have 3 times negative 1. So we'd be looking for 2 things that multiply to negative 3, add to 1. I can't think of anything off the top of my head. So I will go straight to my quadratic formula. So in that case, this value coefficient in front of our cos squared term is our a value, which is 3. In front of our cos term without that square, we don't have anything, so technically that's a 1. So our b is equal to 1, and our c equals negative 1. Now, one difference from, say, Precalculus 11 when you were using your quadratic formula is we didn't have a cos or a trig function here, so it was x is equal to your quadratic formula. Now, in this case, because we have cos x, it's going to be cos x is equal to, and then our quadratic formula. Okay, so we will start filling in our formula. So we've got cos x is equal to negative b, so negative 1 plus or minus the square root of 1 squared minus 4 times 3 times negative 1 all over 2 times 3. So we'll go through and simplify this. We've got cos x is equal to negative 1 plus or minus the square root of 13 over 6. So we will calculate each possible value we can get for this. So we have negative 1 plus root 13 over 6 and negative 1 minus root 13 over 6. And that's going to give us 2 answers. So that gives us cos x is equal to 0.4343 as well as negative 0.7676. Now we're going to draw out a couple of coordinate grids because we have essentially one situation in which cos is positive and one in which it's negative. So for cos is equal to 0.4343. From cast rule, we know that cos is going to be positive here and here. So now we need to get a reference angle. So to do that, we need to make sure we're in radian mode because our domain is in radians. So we'll go x is equal to cos -1 of 0.43, which gives us 1.12 radians. So this is 1.12, and then this reference angle is 1.12, but we're going just to positive pi and to negative pi. So therefore, this overall angle down here is negative 1.12. Now for this one here, we've got cos x equals negative 0.7676. So we'll get a reference angle. Actually, we might as well draw out what quadrants we're in. So cos is positive in these two, so therefore it must be negative in this one and this one. And now we'll get our reference angle. So we've got x equals cos -1 of 0.7676. And that gives us a reference angle of 0.70. So this is 0.70 and this is 0.70. Now to get this, we know from here to here is pi, so it's going to be pi minus 0.70, which is 2.44. Now going from here to here, we know that this is going to be negative pi, but we're short by a positive 0.7, so we're going to have negative pi plus 0.7, which gives us 2.44. So overall, our answers are x is equal to, we'll do this in increasing order, so negative 2.44, negative 1.12, 1.12, and 2.44.